So what we're going to take a look at now is addition and subtraction of algebraic expressions. And here's the idea. Here's why we want to do this. Look at this expression here. So think of expressions as computing instructions. This is a set of instructions for taking values of x and y and converting them into one other number. Here's an example. Let's suppose that x is equal to 2 and y is equal to 5. So what we would do is substitute 2 in for x, 5 in for y, and then compute. So let's do it. So this is going to give us 5 times x, but x is 2, plus 3 times y, which is 5, plus 2 times x, which is 2, plus 4 times y, which is 5. And then computing, we're going to get 10 plus 15 plus 4 plus 20. And if you add all of those up, well, let's just do it. Right here, we're going to get 25, and then plus 4 plus 20. Right here, we'll get 29 plus 20. And then adding these two, we end up with 49. So this set of computing instruction tells us how to compute with the 2 and the 5. It says to do all this. Well, let's take another look at this set of instructions. Let's look at it a different way. Up on the top right here, I'm going to rewrite it again. So we'll get 5x plus 3y plus 2x plus 4y. And here's what we notice. We got 5x's here, and then to that, we're going to add 2x's. So I got 5x's and 2x's. That'll give us a 7x. And then we've got these 3y's and 4 more, right? We're going to have 3y's and we add 4 more, so that gives us 7y. So what we've got now, we're saying that this set of instructions can be made more compact and probably more efficient with this set of instructions. They'll give us the same result. This is just more compact and more efficient. Now, more efficient in this sense. Let's again suppose that x equals 2 and y equals 5. And then substituting those values in, we'll get 7 times x, which is 2, plus 7 times y, which is 5. This will give us 14 plus 35, which is 49. Now, we got 49 using both sets of instructions, but this set of instructions got us there more quickly, so it's more efficient. So how about if we started with this one? We've got negative 16x minus 6y minus 17x. Now, let's combine the like terms. I got negative 16x's, and then we're going to subtract 17x's. So what I'm thinking, now I'm not always going to write this, but what I'm thinking is this. I've got negative 16x's, and then I'm going to subtract 17 of those x's, and then I'll have the minus 6y. So this step here, this is probably a step that you do in your head, right? That's in our brain. So we just think this, but when we just actually do it. So when we get negative 16, right, negative 16 minus the 17, that's going to give us negative 33x's minus 6y. So this is the simplified form of this. Let's try to simplify this expression here. It's a set of computing instructions. Let's try to make it more compact and more efficient. So first of all, what I see is I've got a 17, and from the 17, we're going to subtract 14. Let's keep track of what we're doing here. I've got a 17. I'm going to subtract that 14. I'll leave a little space there. That'll give me a 3. Then I've got 7 r's, and over here I see a subtract 2 r's. So 7 r's minus 2 r's. Let's keep track of that. I got 7 r's minus 2 r's. That's going to give us 5 r's. And then we've got 11 k's, and we're going to subtract 2 k's. So I've got 11 k's. Let's subtract 2 of them. That'll give us 9 k's. So what we're saying now is that this expression is equivalent to this expression in the sense that if we put numbers in for r and k and compute here, we'll get the same value. This is just more efficient. It gets us to the final value more quickly. Now in this problem, we have negative 6, and then we're going to subtract this entire expression. So what I can think of is if I change addition to the opposite, I really want the opposite of all of these numbers. So the opposite of 6 is negative 6. The opposite of negative 3p is 3p. Or we can use this rule is pretty standard. When you see an expression, a set of parentheses, preceded immediately by a negative sign or a minus sign, you can drop the parentheses and change the sign of every term inside. So what we're going to have is going to be this, negative 6, and now minus 6 plus 30. What I've done is I dropped the parentheses, I changed this sign, and I changed this sign. And that's minus 30p. So, negative 6 minus 6 is negative 12, and then plus 30p, and that's as far as we can go with that one. In this expression, we've got two sets of parentheses, here and here. Now, this set of parentheses in the first term is preceded by no sign, and the rule goes like this. If you have a set of parentheses preceded by no sign or a plus sign, you can just remove the parentheses. So let's just do that. 3x plus 9. And then over here, here's a set of parentheses preceded immediately by a plus sign, so I can just remove them. And that will give us negative 4x plus 8. And now let's combine. 3x's minus 4x's is negative x, and then plus 9 plus 8 is a plus 17. So this set of instructions can be replaced with this more compact, more efficient set of instructions. Let's simplify this expression here. Now notice that in the first term here, this set of parentheses is preceded by no sign at all, so we can just remove it. So x plus y plus 6z. But in the second term, this set of parentheses is preceded by a minus sign. So what we'll do is just remove the parentheses and change the sign of the three terms inside. So the 4x will become minus 4x. This minus 5y will change the sign, becomes plus 5y. And the plus z over here becomes minus z. Now let's combine terms. We've got an x, and we subtract 4 of them. So 1 minus 4 is a negative 3x. And then for the y's, here's 1y, and we're going to add 5, so we've got 6 y's. And then with the z's, there's 6 of them here, and we're going to subtract 1, so we've got 5 of those. So we're saying that this new expression with 3 terms is equivalent to this expression here that we started with, but it's more compact and more efficient for computation. In number 6, we've got a set of grouping symbols and then another set inside. This is called nesting. So inside this one, this grouping symbol, we have this one. So we're going to work our way from the inside out. So what I'm going to do is just kind of rewrite this a bit. Let's 6 plus square bracket 3x. Now, let's remove this set of parentheses right here. This set of parentheses is preceded immediately by a minus sign. So I'm going to remove the parentheses, change the sign of each term inside. So this will give us a minus 3 and a plus 5x. Now we can simplify inside here. So doing so, I can see the 3x and the 5x. All right, so we'll get 6 plus, and what do we get here? 3x and 5x is the 8x minus 3. Now, this set of grouping symbols is preceded immediately by a plus sign, so we can just remove them. So we'll get 6 plus 8x minus 3. And then the 6 minus 3 will give us a 3 plus 8x. So now we're saying that this set of instructions up here can be replaced with this more compact, more efficient set of instructions. So in this one, here's a set of parentheses preceded by a plus sign, so we know we can just remove that, getting 5y plus 8. And this set is preceded by a minus sign, so we can remove them, the parentheses, but we have to change the sign of every term inside. So this is going to be minus 2y plus 3. And then you got a 5y minus 2y. You start with 5 y's, and then you subtract 2 y's, leaving you 3 y's. And then the 8 plus the 3, well, that's an 11. Now in number 8, we're given this triangle, and we're asked to write an expression for the perimeter. And the perimeter, you know, is the length around, so it's going to be The perimeter is going to be this. It's going to be x plus y plus z. That's going to be the perimeter. But here's what we're told. We are told here that x is equal to a plus 25. Y, let's actually make that a y here. Y is equal to a plus 99. And z is 3a plus 87. So now, if we add these together, right, if we take x plus y plus z, we can actually just do it vertically the way we've written it. So just add these down, and we are going to get, right, I'm just going to add them all together. So I get a plus 3a, well, that's 5a's. And then, now I did this on my calculator, if I take 25, subtract 99, add 87, I came up with 211. So here's an expression that we can use for the perimeter of this triangle. So if we ever know what A is, if we know what A is, we can just put it in here and compute. Multiply by 5, add 211. All right, and here, in this problem here, nothing new here, right? A set of parentheses preceded by a plus sign. Let's just drop them. 7x plus 15. A set of parentheses preceded by a minus sign. Let's drop them, but change the sign of each term inside. So this will give us minus 3x plus 8. And then 7x minus 3x is 4x. 15 plus 8 is a 23. Now, in problem number 10, what we have going on is this. We want to determine the difference in the altitude. Now, the difference means a subtraction, right? Something minus something to get the difference. So what we're going to do is we're going to take an object and drop it from a 14-story building to 180 feet below. Let's get a picture of it. So what's going on with this one is here's the ground down here, of course. Here's our building, and it's 180 feet high. We're going to take an object and drop it off. And this formula here gives us the height of that object at any time t. So like if t is 0, right, you haven't dropped it yet. You're right up here. T is 0. T is the number of seconds that pass since we drop it. But if we haven't dropped it, 0 seconds have passed. And if you put a 0 in here, that whole term is 0, and you get 180 feet. So at time 0, just before we drop it, the altitude is 180 feet. Now, we've got a second building, and we're 30 feet off the ground here. So we're going to drop an object from this building 30 feet to the ground. So what we want to know is, what is the difference in altitude? Suppose you drop this one, and I drop this one at the same time. This one's always going to be closer to the ground, but what's the difference in the altitude between yours and mine? Well, your altitude is given by this expression, negative 16 feet squared plus 180 feet, and mine's given by this one, negative 16 feet squared plus 30 feet. And we want to know the difference. So I want to take your altitude, subtract my altitude. So let's do this. Here's a set of parentheses preceded by no sign at all, so we can just remove them. That'll give us negative 16 square feet plus 180 feet. And now this set of parentheses is preceded immediately by a minus sign, so we can remove it, but we have to change the sign of every term inside. So this will give us plus 16 square feet minus 30 feet. And then combining like terms, here's negative, let's draw it in here. Here's negative 16 square feet and positive 16 square feet. Those go out to 0. 180 feet minus 30 feet, that's 150 feet. That's what we're looking for. That's the difference in the altitude at any particular time while the objects are in the air.